it's Judy Warner. Welcome back to this week's Ecosystem Podcast. We've all heard of full-stack software engineers, but today I have a friend who coined a term, full-stack hardware engineering. He's going to talk about his decades of experience doing hardware, software, startup, teaching at university. He has a wealth of information and a wealth of wisdom that'll teach you to think differently and really engineer with purpose. I think you're really going to enjoy this conversation with Eli Hughes. Make sure you go like, subscribe, and opt into our newsletter and our online community at theecosystem.com. Now let's jump into our conversation with Eli Hughes. Hi, Eli. So good to see you. Thanks so much for joining today on the podcast.
Hey, Judy. Thanks for inviting me.
It's always, you and I always have so much fun talking. We definitely go down a few rabbit holes. For our listeners, why don't you take a moment and talk about your background educationally, engineering-wise, and just give us a brief overview of the kind of work you do today.
Sure. Well, I'm Eli Hughes. I currently live in central Pennsylvania, State College, Pennsylvania, or Penn State Nittany Lions. I'm actually Pennsylvania homegrown from Northwest PA, up in the Allegheny National Forest, kind of what they call the PA Wilds. I went to Penn College to learn electronics. So, boy, I say it doesn't sound like that long ago, but now I say I started in 96, graduated in 2001, was on a 5-year plan just because I was pretty much working full time as well towards the end. Started my career doing R&D in power electronics and digital signal processing for a company that did a lot of Navy research. And it kind of led me to State College because there was an acoustics program. You could get a master's degree in the science of sound, which is a lot more than audio. It's the study of basically everything that wiggles, vibrates, compresses, expands in the universe. It kind of led me into working at Penn State ARL on a lot of different things, from undersea vehicles, sonar, robotics, even some space projects. Kind of led me through a startup doing some beer fermentation monitoring using acoustics, software, electronics, and now I'm just kind of full-time doing kind of technical contracting and content creation, as well as some work for NXP Semiconductors.
So we had some fun together, and when I was at Altium, you keynoted for us. We did some podcasts together, and I thought for our audience here on the ecosystem, there was one that was particularly popular that I want to sort of bring back, to unpack here together, and that is this term that I think you coined, and as far as I can tell on Google and you on Bing, is the idea of a full-stack hardware engineer. Now, we're used to hearing about full-stack software engineers, so let's unpack that. Like, I think people know that they need to pay attention to more than one part of their engineering. So why don't you unpack that for us? Tell us what you mean by full-stack hardware engineering, and then we'll jump into the rest.
So I'll start this by giving you one of the best responses I ever heard from a question. So, I play a lot of music, piano, guitar, into a lot of classic guitar rock. And one of my favorite bands, ZZ Top, there was an interviewer in Guitar Player magazine, the guitarist from ZZ Top, and they asked, so tell me, we just have to know, is ZZ Top a rock band or a blues band? And he's like, yes. I just loved it. It's like, so that, I just want to lead into what is a full stack hardware engineer? So, you hear the term a lot, and it's actually, when it's used in the software context, it's actually still pretty narrow. It's used mostly in the world of kind of web development and, the internet, where it kind of describes someone who, it's an engineer that can handle the front end, meaning all the things you see on a web page, the fancy graphics, the layout, all of that logic. And then someone who can also do all the stuff, all the plumbing you don't see, the databases, all the things that connect, that actually make it work, the plumbing in your house. And, someone can kind of do both of those. Is called full stack, which is always interesting because for me, software, while you know, coming up before the internet kind of existed and kind of living through it in the early days of the web, I'm like, there's a lot of software that doesn't touch any of that. It's like you're leaving all of that out. There's all the embedded software, the software in your car, in your microwave, every embedded system in rockets. Like,
Yeah.
and it got me thinking too, even in the hardware engineering space, that it always bugged me that people say, well, I'm an antenna person. Well, I do analog. And I'm like, well, why are you bounding why would you even say that? Like, why would you say, no, I'm here to solve problems? And, so when I think about full stack hardware engineer, it's about this idea of service. And I've been really thinking about what it means of when you're asked to help to build something, whether it's sweeping the floors, designing the circuit, writing the code, interacting with the vendors, being there on the weekend to help out, helping other people. When I think of people kind of like to the left and the right of you, up and down, you're in this pipeline. And if you can extend yourself a few steps back and forward to make their lives easier, that's kind of the essence in the hardware space of there's kind of people before you in the chain, but there's people upstream after you. If everyone can be thinking about those kind of two directions, that's kind of what that means. So that could be everything from, your analog design, your antenna, but it gets to microcontrollers and circuit boards and then the software. So much of even an electrical engineer today is software, both on the PC and writing things like in a microcontroller. So it's really putting like a circle around that from the technical side. But then there's another component that's even left out of the full stack side on the software, is that you're going to be limited. Effectively, one person can do so much. You're only as good as the team around you.
Right.
You've got to connect with them. You've got to hook up. That's a social problem. Those aren't problems that are solved through pure mathematics or, you're trying to like connect with other people in an organization. There's a whole set of engineering around that of how do you work with other people. And when you put those together, to me, that's kind of like the full stack.
I love that. And I remember when the first time we talked about that, you talked about, I think of it as situational awareness, but we've talked about a term that I remember from 100 years ago, which was contextual engineering, right? Or in situ engineering. So to me, it's situational awareness. You had used a term that said to have awareness of your downstream and your upstream stakeholders, right? This idea of getting out of the silos and throwing things over the wall and saying, tag, you're it, and not knowing whether you've been helpful or hurtful, right? And so, and as we all know, it can get really messy really fast. So, in your mind, I think of you as a full stack hardware engineer because of all the pieces you touched. I'm sorry, what were you going to say, Eli?
No, so I was just thinking out loud, and the reason I used like kind of forward and backward in the pipeline, but I also think about, I'll say up and down, because I think there's a component. Another thing that always bugged me, and I was conditioned to this, and I'm now fully aware of like how wrong I was for a while. And part of it was just how it's kind of taught, not only universities and culturally, is that if you're in engineering, you're kind of thought of like, we're in engineering, and those people in like sales and marketing, they're these evil liars that are like out to get you, and like we're doing the real work, and they're doing something else. And something about that bothered me, like that it can't be true that we're always on team good and they're always on team bad. That doesn't exist in the universe.
Yeah.
Like that in any. And then I thought, well, what if you had people in marketing interacting with people in sales and engineering in a healthy way, that you're helping each other? What could you achieve?
Right.
Like it's like you have to think about that of like what, and then stop thinking about these siloed roles that
Mm-hmm.
maybe one day you are part of the marketing team because you're helping teach and explain. And sometimes marketing is helping teaching you of saying, hey, here's what our customers are telling us. You need to be listening. And you're not listening because you're in your silo. And there's
Yeah.
so much about like listening to other people and approaching it from this point of view of service, of you're there to help and to serve others in this space, and by doing that you're going to get a lot out of it, both direct and indirect. And so that's why thinking about who's behind you and who's ahead of you, because sometimes you're doing something, it might be you're doing something that you have to pick up in a few weeks and you're just leaving your breadcrumbs to help you. But I've just found that buys so much goodwill that
Mm-hmm.
people want to keep working with you because it's easy, like you're on the same team, and it just makes things a lot easier.
And I think we get in those hierarchical traps too. And we believe this stuff we tell ourselves about, all of that. And I love what you're saying because, and I like the idea of an ecosystem. Every part of that ecosystem has value. I think about that video that was out where in Yellowstone they'd killed off all the wolves, right? And then like 10 years later they reintroduced them and it completely transformed the park and leveled everything out. And I think it's the same in hardware, in electronics design and development, right? We all have a place, and to value our place and another's place, and that we're all doing this together instead of fighting over the gold star or whatever it is we're up to. So
Yeah,
go ahead.
yeah. And it's hard. It's sometimes hard to put the finger on, but it's always kind of be willing to like listen and learn. And uh, I don't know. It's that box of like I'm a this person or I am that. It's like, well, maybe I'm just here to help, and maybe that looks different. And I certainly have biases of the things I like and the things I'm passionate about, and we all do of like certain lanes or certain types of engineering because it's personally interesting. But even within those spaces, there's so many like different ways you can kind of plug in and be helpful. And that I don't know. There's just so many positive benefits to it that
So
it's made my life a lot better.
yeah, and me as well in a different context. So you had told me a story once. I don't remember, Eli, I'm sorry, where you were working, but you had got stuck and your upper downstream stakeholder was like over in another building, and so you took a walk. Can you retell that story for our listeners?
I have a couple of them. Yeah, so it's tough, like because sometimes when you need to draw upon other people. There are times when you think you have everything figured out, right? And it's X, Y, or Z, and like you think I can do, and you see this so much in engineering, whether it comes through like, you know, like the not invented here syndrome, or I've got to do everything myself. I can't give up this piece because if I give up this piece, it's my piece, and there's only so many pieces, and um, sometimes the best thing you can do is put down what you're doing and help someone else because that gets paid back in dividends. And the problem is we think in terms of reciprocity that what you get back is instant. What you get back may pay a dividend years down the road. And you have to live with being unsure if you're going to get paid back. And that's where kind of like the trust and the faith part comes back. But there's been several scenarios like that the best thing I could do was if I'm stuck or having a problem is help someone else with their problem. And through that, directly or indirectly, I'm going to get my solution to what I'm doing. And it may just come like out of like from outer space, like of like, what it is of like, the idea that kind of helps me break through. But yeah, every time I'm in a funk, putting what I'm doing down and just figuring, well, how can I help someone else right now? Like, what is it? It could be sweeping the floor. Maybe that's all it is. But the kind of network effect that it has is
Yeah.
incredible, and it's something that people in sales know about. Like they've
Mm-hmm.
tapped into it because they know about it. Engineers and it's probably more than just engineers. There's a lot of people of that ilk don't really understand that network effect because they're thinking about causality. If I do X, I get Y, then I get
I
Z, and
see.
it leads to this. Problem solved. Papers done. Where a lot of these other soft skills come from I'm doing this thing to plant and grow, and it's going to grow it's not going to grow the way I think it is, but if I do this system over and over, the yield I get down the road is incredible. And I'm okay with if the yield isn't what I expect because it may pay a dividend I could never have planned.
So give us an example of how that played out in your life at some point. I know you've taught at Penn. You
Yeah.
have been on a large engineering team. You've been on tiny startup teams. Like, give us like one of your fave didn't see that coming
Oh
moments,
gosh.
so our audience can have a concrete example of what you're discussing.
Yeah, and what I'm trying to do now is not think of the example, but think about how I ended up, like the time frame over which we're talking about. I got to like put some bookends on it. I'll get maybe I'm working on a job like right now. I am working on a project. It's, a little bit not secret, but, it's not advertised. Doing a new guitar design that's going to tie in some artificial intelligence, some digital signal processing. And I met someone in Jakarta, Indonesia, who's not an engineer, and they're like, how in the world did you make this connection who can connect you to some guitar factories and this other thing that you can put this all together, who are now getting connected to these other people? I'm like, well, that came from, well, I was doing this other thing, and then I did this other thing, and you lead it all the way back. Oh yeah, one time I had this idea, and I just told someone about it, and they said, hey, do you just want to show me? And it just led. It was like it's this whole thing of like yak shaving. So that we use this like concept of you can end up shaving a yak if you just don't put things down, and you end up doing. But that also kind of goes the other way. That sometimes how did you end up with this relationship, say with NXP doing these cool chips? I'm like, well, it ended up because 15 years ago, someone asked me, hey, I don't know how to do this. Will you help me? And I said, I'll just help for free because I want to do it. Well, that led to them telling their friend, hey, this person helped me. He kind of knows what he's doing. They'll ask, and I'll say, yeah, I think I know. I can help you too. X goes to Z, and you're not putting maybe a dollar figuring on it. You're not saying what's in it for me right now.
Mm-hmm.
But it generates this chain that it generates some connections that little thing ended up with me being involved with this big semiconductor corporation doing these cool projects and then meeting someone halfway across the world. Like in it's like the yak shaving thing. If you saw this story, it's unbelievable. And if I have to repeat it, I almost can't because
Well,
I can't. I literally can't because I can't remember every chain
let
because
me
I don't know
save you
who.
from that. Let me save you from that because I actually wrote a blog about yak shaving, which came from Seth
There
Godin,
we go.
and I will link below the blog I wrote, and it's on LinkedIn. So it's about somebody went to get their sweater from their neighbor and whatever, and they ended up shaving a yak. Like it's going down. It's not following the track the right way, and things end up being much harder than they should be. So, anyways, I'll save you from that, Seth Godin, and I'll link it below.
Yeah, and a lot of time it's putting yourself out there. And even my relationship with NXP, it started with their university programs of, hey, you want to help us teach students at Penn State? I said, yes, we put curriculum. This led to that. I started doing blogs and content. It led me being introduced to other members in the team. It circled back to other people in marketing saying, hey, do you want to write more blogs and content? And it's this long cycle. And it's kind of related to a different concept that actually, once I saw it just the other day on social media of there's a classic kind of meme or theme for like science fiction of like if you could go back in time and change these little things, like we could undo the Holocaust and think about what the future could be if we could only go back in time. The thing that's missing from, I don't think anyone ever connects, is we're thinking about here and going back in time. That works the other direction. Things you can do right now can affect the chain of events in the
Right.
future, that there's this effect you can't predict, that you don't actually have to think about going back in time. You can start actually right now and go to the future. You just might not know what it is. You just have to take off the analytical hat a little bit and think about a network effect that can happen, that can be very, very positive.
Well, when you think about electronics device, what would it be without any interconnects? It'd be a dead chip or something.
It doesn't work. Yeah.
You're right. Or
And
it'd
it's like
be
the
a
interconnect.
capacitor laying on the floor, right? Unless all those
Yeah, it kind
interconnects.
of doesn't. And that's kind of and you see this in across all domains. It's musically, you could be the best guitarist or pianist in the world, but if you don't have an audience to play to or other people to help record you, or if you don't have the network around you, it becomes somewhat pointless. So the connectivity is, and we see this whether it be, the internet and AI, the connectivity pieces are as important as everything else. Everything from cells in your body and your brain to humans working together, the connectivity piece is really important, because it's a lesson I learned several times that putting a bunch of smart people just in a room with some money doesn't actually get you anything. The relationships between them and how they communicate, you can take not the smartest people in the room with great connectivity and make something awesome. And it only gets better when you have really good people doing really
Right.
interesting things with good connectivity between them.
Right. And
It's
people being
everything from
givers, like you said, instead of, having poor motives or
it's
whatever.
same thing with rock and roll bands. Some work, some don't, and some of the ones that work the best aren't the best musicians on their own, but when you put them together, it's
Yeah.
something else.
Yeah, for sure. So when you think of full stack for civilians like me, like what are those pieces you think about? Circuit design, or say packaging, circuit design, components, board layout, like what does that full stack, how would you define that? Like what are the pieces
Yes,
of that full stack?
I'll start with the piece that once I got it was a linking piece that
Okay.
linked. It's by itself not the only thing, but I'll call it like one of the linking pieces. So I started out really young getting interested in software because the Apple IIe, and the Nintendo Entertainment System, programming. I think I was like in seventh grade, and it was in that Altium keynote, like the whole story. And I thought I was just going to be software because at the time, my father was into electronics, and what I knew of electronics, he fixed old boring church organs, which was old analog. I was like, I don't want to do that. That's hardware. That's boring. Until I saw that there were people like at Penn College saying, hey, we're going to take this board. We have a robot. We have all these wires hooked up to it, and we have software controlling the whole thing. And then I'm like, oh, wait a minute. Like, actually, the full stack is all of those pieces. But the
Mm,
linking piece to me was when I actually learned on Protel before it was Altium. It was
mm-hmm.
Protel. We had a course in circuit board design, which linked, we worked with devices on breadboards and we learned the theory, we wrote some software, but the instructor who had us learn how to use the circuit board software, we etched boards ourselves so we could put more advanced components in a package to do more advanced things. But he also took us to 3 different contract manufacturers to see the upstream and the downstream. Everything from shipping, receiving, bringing it in, parts getting on boards, 50, women, and like when they manually place things, to, because women are actually just better at it. They are
They
like,
are.
to the people testing it, to the people programming it. That circuit board was a piece I saw was a linking piece that I got addicted of. Like, that was the piece that got me from, okay, if I want to write code, but I have these other chips over here that aren't in the form I want, and I can't airwire it. I need this piece to connect those worlds. And even today, when I generate content, I'm making custom circuit boards. They're like ephemeral. They're just something I use as a canvas that
Yes.
you see, like the skulls back there with the eyeballs. All these other pieces are held together with these circuit boards linking them together that are just, for me, that's the piece that tied together everything from raw components to microcontrollers to antennas, packaging. Then once it's on the board, then we can start thinking about software and everything upstream. And that for me was that key piece in the middle.
What was so funny to jump off that. So I started a million years ago in the board industry, and boards, PCBs, were thought of like, ugh, the components were the sexy part, or the, programming FPGAs or whatever. And I'm like, I'm just a little circuit board. And it was mostly manufacturing and assembly, right? But working with engineers to help them make better designs or panelize them differently so they would be cheaper, faster, all those things. And I was thinking, oh, me, I'm just a lowly PCB. Well, turns out it is the linking piece, and it led to me doing what I do now, is to talk to people like you. And it's like, who knew, and the board effects right now, especially with high speed or all that, it's the problem child. So I told my friends who are gifted, they work for Wolf Speed and they design chips and all this stuff. And I'm like, hey, guess what? I'm relevant again. I felt, once everything got outsourced to China, I'm like, oh, I'm, a commodity. Nobody cares. And it's like, well, turns out all the crazy stuff's happened at the board level now. So who knew?
Yeah. Well, it's germane, because now all that stuff you learned about, like in electricity and magnetism, that you could kind of disregard because of the advances in packaging, chip geometries, everything. That board is almost, when I think about, I love architecture, I love old buildings, I love looking at old buildings and just how magical they are. But at the same time, a circuit board, when you look about the sum of human endeavors and everything we know about materials and everything in chip design and board design, it's like its own little system there. And for me was really cool. And
that's interesting.
The other thing I'll relate, when I worked at the Applied Research Lab at Penn State, I taught part-time, and I did a senior project design with microcontrollers. And one thing I made every group do, whether their plan had it or not, it was a requirement that your project, not that you went out and bought dev boards and put them together, you had to design a circuit board of some complexity, whether you knew how to or not. I said, we're gonna do some teaching here, but your job is to make this circuit board. And I had some very specific requirements, and some of the students would push back and say, well, we were never taught this. I'm like, so what? I was never taught a lot of things, but I'm telling you.
Right.
But I said, there's a very important reason why. Most of you may never actually do one again. But some of you might be going to management or sales, but going through the process of raw parts, through prototyping to building to soldering to programming, you're going to see that process to some degree, and it's important to have that context of how you do modern. It's not just air wiring on your old breadboards. Like, doing it once, even if you never do it again, gives you a certain amount of context. So if you're managing someone who's doing it, the importance of it.
Well, and that's a good point, is that you can have contempt for things you don't understand, right? So if you take the time to understand them, you'll appreciate it. And
oh yeah,
right. And so
whether it's other humans, other cultures, other technologies, most of the time, I have a buddy he's really on the software side, and software people are really hard on each other. When they look at their work, they tear it apart and they say, why'd you do it like this? I would have done it like this. But he says the reality over doing it for 20 or 30 years, anytime when you have that kind of contempt, when you really look at what was driving why the software it is, most people, you would have probably ended up with that same piece of software, give or take 15%, because if you don't have the context of here are all the things that are going on, here are our
Right.
constraints, here's what we have to work with, it makes sense. Like, yeah, you're not going to tear it apart because like you'll understand the context a little bit better.
Okay, so let's unpack that a little bit. So, in your mind, again, because you've been doing this for a long time in a lot of different settings, academically, startup, laboratories, all these different, and now with doing content for NXP or other companies, you've had this breadth of experience. So, in your mind, I know you're pretty passionate about this subject. So, what would you say the benefits are to adopting this mindset and this practice? And then let's talk about the obstacles also.
Yeah, the benefits, that's a very good question because it's becoming very relatable right now. There are, I think half of the industry is really scared and half are really excited. Is that, and it kind of ties back to this context. And the reason it's important to understand context upstream and downstream and linking things is that tools and technology are always going to change, and they're going to change in ways you don't expect. So you think
Yeah,
about, let's say 5 or 10 years ago, when Tesla Elon was talking about self-driving cars, and then the writing was on the wall. Guess what? Truckers won't have a job, or these certain workers won't have a job. We're going to automate it away. Guess what actually happened? ChatGPT 3 and now 4 got released, which can now write some pretty remarkable pieces of software and do creative works that the people who thought their jobs were safe in one turn of events in the context of a year went from not maybe people, the blue collar workers leaving their job. Guess what? Trucks are still driving to deliver everywhere. I can now use these new AI tools that one engineer can maybe do the job of three or four, or maybe I don't need, the same amount of people to write these pieces of code because we have tools. So be very careful about whose job you think you're automating away, because one change, the people that thought were untouchable, we can demand these salaries. Guess what? It changed overnight. And the reason this context matters is even in content, someone says, well, why are you doing this? AI is going to just write these articles. I'm like, yes, AI is going to help me write these articles. But the thing, if you have context, you know what's garbage and what's not. When you have the
right.
context of how these things are going to be used, what the end goals are, sure, there's going to be a lot of noise. How easy then is it to separate yourself from the noise when everything's the same? It's actually pretty easy. So
Yeah,
having context outside of maybe one piece of engineering that you can link things, you're in a better position to help someone else somewhere else. And it may be using these tools in a different way. And it's this mindset of, if I have this thing, my job goes away. It's like, well, yes, having the car meant we have less buggies, but there's more jobs than there ever were because it
right,
changes. And
right.
being willing to adapt with it, and also be willing to accept, just because you think your job's safe now because, yeah, the self-driving is coming, well, that turned out not to be as, it turns out the creative jobs, what you have to be creative at's now different. And
Yeah.
that's
And
where I
what
think it's
feels,
helped.
and I think you're right. And that wisdom comes with age, hopefully. And the things that you think may be safe may put you in danger. And so, what I hear you saying is be a hardware engineering Swiss Army knife, because with breadth of knowledge and experience, there's more opportunities to both serve and to be useful, right? And it's like everywhere you go, bring value, right? And
Oh,
do you think,
100%.
and so what do you think COVID's done? All this isolation. I mean, in one way, here we are, we're podcasting on, a podcast app that's in the cloud. Yay. We don't have to do it in a physical space. So in one way it's enabling, another way it's isolating. Like, what ways do you see, benefits? And then we're going to go into the obstacles of benefits of COVID, say, and then, maybe obstacles, or ways that we've reinforced working in a silo, because we are in silos now.
Yeah, I sit on. I have two different probably thoughts that are complete. They're the same but different. They're opposite but they're not. On the positives, all right, here's what we found out. Companies can be very profitable, even more profitable, with a distributed model for certain types of jobs where you don't need 1,000 people sitting an hour in traffic to go sit in a frickin' cubicle. Those
Right.
things don't need to exist. We figured that out.
Mm-hmm.
That being said, it's really opened up to do remote hardware engineering. I was on a project 6 weeks ago with a team in Italy. I'm working with a team in California. I'm working with someone in Jakarta. It's beautiful. At the same time, my friend in Jakarta, he's going to end up in Chicago. I'm purposely saying we're going to meet. We have to, because like there are times you have to be physically together, because some of the best engineers, once we got aligned and we're in the same space, we could solve problems so quickly
Right.
because we're there, we're just dealing with it. So
Mm-hmm.
there is a physicality that is very important. But then there's times I just need to be left the frick alone. I just want to go in my bed. I just want to sit here in my lab. I just got to crank it out. But there's days I have to leave. I have to be interacting with people, and there's
Yes.
value in that. There's a
Yeah.
ton of value. Um, and I think the thing that COVID was showing, yeah, there's some things we're doing that are pretty dumb. Like we don't need to do this. But then there's also some very important things. Humans, whether we like it or, and I used to be, I don't need other humans, but the reality is we do. Like, we don't, like, it's that no man is an
Yeah.
island. Like,
Yeah. And
we're
if we didn't learn
connected.
that from COVID or from what's happened to our kids or anything else, if we didn't learn that from COVID, I don't know what we learned.
Oh, gosh. And it's both one of the negative things of COVID, which was also at the same time a positive, was that we all had a lot of time. We
Mm-hmm.
were, in different forms locked down. Um, we kind of lived in isolation. We weren't communicating. Uh, what even before then probably wasn't enough, but it got worse. So you don't know what other people are thinking. You're now thinking, am I good enough? Engineers have this problem. Am I good enough? Am I doing the right thing? There's this, do I measure up? Am I as good as Eric Bogatin? Well, guess what? You don't have to be. Like, am I as good as Rick Hartley? No, I'm not, but I'm going to learn from him. I love that he's so wicked smart, because it means I can grow. And so that imposter syndrome, like, I think it gets worse because if you're not interacting, you lose that. Okay, these other humans have faults too. They're not perfect.
Mm-mm.
Like, and they got there through little steps, just applying a system over and over and over again. And it's a negative part that makes it worse. And engineers, I think, because you're already living under this meme or this assumption that you're antisocial, which isn't always true, but
It is not
amplify,
true.
you really are alone.
Right.
But
Mm.
there are some things that, like, you're even more siloed because you're on the other end of the computer and you're just not talking to people, and it does hurt in those kind. And I see it. The imposter thing is really limiting. That you are good enough. Like, even in whatever state you are, you just have to do it with a set. You have to. It is hard getting that confidence because you're always going to run into people that will bring you down. But I do think they're in the minority. Like, now
Yeah.
that being said, here's how I can antagonize and maybe get people thinking of. I've heard engineers and non-engineers alike of, like, if only I had the time to learn about this new thing that would get me, whether it be a piece of software or doing the
Yeah.
project. Like, guess what? You had a year and a half. You were locked up. You weren't allowed to go to the freaking grocery store. And what did you do? Did you do it? It
Yeah.
didn't sound like it. Why didn't you do it? Why didn't you take 10 minutes a day? Like, what was keeping you? We literally we ran the experiment. Everyone had the time, like, because you were forced to. And did you
Yeah.
take it? And then,
Yeah.
that it leads me to what, gosh, and this was so impactful. And it was such a small statement. But it's so big. So early in my career, my first job, doing some of this research for the Navy, we built this box. I'll just say it is this big giant box. It cost a lot of money, had all this electronics, this DSP, and we drove it to Lawrence, Kansas, to another small company who was doing something for the Navy to put it all together. And there was a guy working there who was introduced as like the machinist, but he wasn't a machinist. He had a degree in art as a 4-year degree and a master's in mechanical engineering. He did things on that Bridgeport mill and put this mechanical stuff together and bridged the theoretical to the real world. And on the side, he built battle bots. He was an artist. He built this bird that was completely made of stainless steel with articulating wings, and just
Wow.
I was like blown away. And we were there for a week, and I remember we were just hitting it hard. He was over at the mill doing something. I said, you know what? I've always wanted to learn how to do this. He's like, no, you didn't. I'm like, well, and I was kind of taken aback. And he's like, and I'm like, what do you mean? He's like, you don't want to do this. He's like, and I'm like, well, why? He's like, Eli, get your head out of your butt. If you wanted this, you would have been doing it already.
Right.
Like, don't say that you have an interest. Just, pick up the drill, pick up the thing, start doing. His point was like, there is a disconnect between saying, I've always wanted to do this and doing it. And most of the people doing it, it's not because they're geniuses. It's because I'm going to start. It's going to start badly, but I'm just going to do it. I'm just going to start out. Like, and that stuck with me when he said, no, and he said it in a tone. He's like, no, you don't. You don't want to do this. And it was a little antagonizing. And it was in a good way, because then I thought,
Kind of like
yeah,
cold
who am
water
I?
on your face. It kind of woke you up to go, oh, yeah.
Yeah, and I'm like, who the frick am I to have this thing to tell this really talented person to say, I always wanted to do, because then I thought I almost belittled him. Yeah, I want to do that someday. And he's like, you know what? I did it. Like, I took the time. You can too. Don't say you want to do
Right.
it. Just, you can start doing it. Like, and that's why with the time, we were in a situation where you have time and resources, and
Right.
and even if they seem small, they're not. You can take advantage of it.
So I heard, to that point, I heard you talking about taking small steps. And I think that particularly in electronics, because the speed of technology, and now I feel like we all work harder and longer than we did before COVID. Like we don't, what is this saying? We don't live to work. We don't work at home. We live at work. Right. And so the line between our personal and work lives have gotten really muddy. And then in some ways, I feel like we're under more pressure. And so we keep saying, I don't have the time. I don't have the time. And I think the challenge is to realize, that old saying that the journey of 1,000 miles begins with one step, and for me during COVID, to your point, is, I've been sitting in a cushy office in La Jolla, California, with a gourmet kitchen on every floor, and you would just go grab a bite of this and grab a bite of that. Well, once COVID came, I'm like, well, I could walk now. I could exercise. So I did. And it was like short walks when I first started. Well, now I can walk miles. But I'm like, wow, that really taught me that it was more about consistent effort over time, right? And those efforts can be small. And I heard someone on a podcast say, if you got 1% better every day over a lifetime, it's probably like your mechanical engineer friend, right? You make steps over time. And that's what I hear you saying. It's not, we and engineers can look at like, I want to learn that thing, but it seems so big and overwhelming. It's not like eating the elephant. But I think that's the right mindset, right? Is to carve out that margin that's called self-educating or whatever you want to do, and actually giving yourself that time. Because 10 years from now, you're going to still be in the same place. Or you could take that 1% a day, and where could you be in 10 years?
Yeah, for me, I've always battled with like weight and diet. And last year I made a few changes, and found out, that it's, if you just make very small things, but just, even if it's 5 or 10 minutes, it's, and I do it now. Like, I don't want to do my frickin' dishes. What can I get done in 5 minutes? I'll limit it right there. And actually, you know what? More than you think, and 5 gets to 10. And whether it's that, it's like I have this microcontroller on my desk that runs at a freaking gigahertz with all this complex routing. It's like, how do you get there? It's, well, I started with like the simplest possible thing, and just over time, little bits of just dissecting and doing, a little bit more analysis and just staying after it year after year, and not expecting like an instant result, but just, you know, uh, little bits at a time. I think it applies to everything in engineering.
Everything that I can
And
think of.
life.
And I really like that point, Eli. And I think part of what drives that imposter syndrome, I can, everyone, I think it's a human condition, not just for engineers, but I think it's an interesting thing because I think engineers are perceived as like that doesn't apply to them. They're so logical, right? And imposter syndrome seems like maybe an emotional response, but I think it's because we know where we started and we see these gurus and we measure between it's
Yeah,
our references.
well, first of all, your references are skewed.
Yeah,
Like the ruler you're using to measure isn't right to begin with.
exactly.
That's the problem, is not only do the thing you're looking at have to be right, the ruler you're using should be calibrated and correct. That's why you got to be
Yes.
comparing to where you kind of were yesterday, not to this
Yes.
other person, but use
Exactly.
them to learn from. But something like a little thing when I kind of pitch like content projects, and when I make this statement, it's going to sound a little antagonistic, but keep in mind, I apply this to myself, and I think it applies to everyone, because we're all human, is that, and I'm going to use the word engineer, but it applies to scientists, mathematicians, anyone, is that, and I'm going to read this: engineers are highly emotional creatures with a very thin rational facade. Now, there's a connecting sentence, and they don't know it, but everyone else does. So all the people that are non-engineers, engineers think that no one else sees that this is the way it is. They think, oh, they're seeing me this rational thing. No, no, you see right through it. It's just people know how to interact with you. And like, once you understand that we're these emotional beings and we have these, we're a system, and you've got to understand how your own brain works, because that's how you get better at the rationality, is understanding how you tick internally. Like, and that's really important. And that's not something you necessarily learn in a book, and that there's an easy algorithm you apply to get there. Um,
Well, and I think if you look
you
at the
know,
horizon at almost like Elon Musk, oh, we're going to go to Mars. That is so far out there, but the measurement should be where did we start? And your measurement is where you are today, is to have a reference point in the rear view and say, this is the amount of gain I've made. There's a book, I think it's called The Gap or the Gain. Anyways, I'll find it. I'll put it below. But that's what it says. We're always measuring ourselves against an unattainable horizon rather than where we were yesterday and how much closer we've gotten. Because the horizon always it's always in the distance, and it's supposed to be. That's how we grow. And so it's, like you said, calibrating that ruler,
yeah,
I'm at,
make sure you're using the right measurement device. And I do think the unattainable thing, I am one that believes, like, I don't ever want, we always think about humans and intelligence growing like with this infinite curve, and we actually think about AI will do this. And I think there's probably some, mathematically limiting statement that can probably be made, that like it's bounded to the point where you can kind of get close, but you're always far enough away to make that next step is like twice as hard. That, I almost don't want to know the answers to everything, because that's part of the excitement, right? Is that you
it
have this
is. Do you
thing that's
want to
just
stop
out of reach.
learning? Do you want to ever? I
Yeah,
don't. And I don't think anyone in this industry doesn't. I think what drives many of us in the technology industry is the continual pursuit and change. We like that. We like that it moves.
yeah, and there's something, and it can be the challenge. The other side is it can be with. That's where the mentorship piece comes into me, of when it seems overwhelming. This is where young and old can learn from each other. Young people have a different world they grew up in, so they bring to the table something that, like, people who are older lived in a different world. So each has
Mm-hmm.
like a different context. But there's the mentorship aspect of sometimes when things seem so overwhelming, when you've traversed from A to B, even though it's different, it's that having things in context of someone to say, look, I get that you're working really hard right now. You're going to get there. And
Mm-hmm.
it's just slowing you down a little bit to say, it does seem overwhelming, but overwhelming doesn't mean impossible. It
Mm-hmm.
means you're going to keep taking steps. And that's where I think having, the tip is if you can find a mentor, like someone or something that can be that person for you, is a big deal, like a really big freaking deal, because that's what can help get you through those times that when you're unsure and uncertain of where you stand, having someone else,
Mm-hmm.
kind of talk to you and kind of lead you through. Both experiences are different, life experiences, but the fact someone's traversed something over some amount of time is the important part.
Well, again,
So,
wisdom. And Eli, I know we're out of time, but I think you are that mentor to so many. And through your content, through doing things like you do today, I've learned tons from you, and we've had really interesting conversations because it's a human condition. And it just applies to
yeah,
engineering, and it's how to get those roadblocks so people can become better engineers or better at whatever it is that piece of that puzzle, so we can be better and
yeah.
grow and bring our best and not hold ourselves back mentally, right, and emotionally. And I really think you're one of those people that have unpacked that, and I really appreciate.
Oh, trust me. And I fight a battle every day, it seems, of like, you know, you know, it's tough because every day, even a person who looks put together is not, right? Every day, even the people that look like they make it easy, it's not easy. That's
Mm-mm.
the secret. It's not easy even for the expert. Like when I bring up people like Eric Bogatin or Rick Hartley, they still face challenges. Like it's all in the approach. But I guess to leave too, the kind of three things, boy, and there's so much to even unpack that I think what helped drive you to this like full stack approach, and they're very soft skill kind of things, but there are three things I think humans need in any domain is you need like this one anchor of like curiosity of like why
Mm-hmm.
things are the way they are. I think a lot of engineers start from there. It's purely curiosity. There's like another piece of adversity. Things are hard. Like, okay, thousands of years ago when we have spears and we're just trying to like hunt for food, like our adversity was, do we eat today? Right?
Right.
But today we have different types of adversity, but
Mm-hmm.
I think it's a necessary component for growth. And then those kind of things at the top like connect to purpose, like purposeful engineering that,
Mm.
and I see this a lot, especially in the social media of engineers building things without a purpose, which is I do it. It's fun, but like then you end up with a lot of things with no purpose, and you wonder what did I do any of this for? It's that when you tie this to some purposeful thing, and I found the purpose of serving other people to help them through something, I grow. You serve this, it drives you when you face the adversity that you don't think you can get through, the purpose pulls you through it. The curiosity of how's this thing, I'm curious, I want to make this work. When you have this kind of three things, any one could be more active at a time, but if you kind of remove one, like it doesn't work. If it's always adversity all the time, it's
Right.
tough.
Right.
But when it's connected with purpose, I'm doing this because for example, if I'm working for this medical company that's going to help someone walk again, the
Right.
purpose isn't your circuit board. You are literally going to help that child who cannot walk to walk, that person who cannot hear to hear again, the person who, like, when you can tie to and the purpose doesn't even have to be that big, but the fact that you enabled something else and you're serving someone else or something else, it's what drives it to be better. And I don't know, for me, I try to keep that as that vision. I don't know always what it is, but on days when I'm in doubt, I try to keep on that of what is the purpose here and how am I helping and serving.
I love it.
And here's the thing: is if you don't know what to do, and it doesn't have to be engineering, help someone else. Like it's such a default. Like if you're just in doubt, it could be sweeping the frickin' floor, taking out the garbage. Like it could be, cooking or bringing. Like if in doubt, don't sit and do nothing. Just help
Yeah,
someone. And
that's a good
you know,
point,
uh,
is resist that.
and it could be in software. It could be an open source project. It could be someone else struggling. It could be, and it could be engineering or non-engineering. And through that, you're probably going to learn something, and it's probably going to connect you to another purpose. So, that's kind of like the self-fulfilling, this motor that you can kind of keep spinning and keep kind of self-propelling.
Like a flywheel.
Yeah, exactly.
Well, Eli, thanks again, and thanks for coming on today to be our engineering Yoda and teach us from really decades of experience and wisdom you've gained. And I really appreciate you being sort of purpose-centric and people-centric, and it really shows up in everything you do, all the content you make, all the engineers you help. So thanks so much for coming on today. I know you're a busy guy.
I really appreciate the opportunity. It's just a good time to talk, and I'll always talk for free. How about that?
There you
I
go.
love doing it. So.
Well, for our listeners and our viewers, I'm going to put some links behind or below for you. And one of the things I'll do is I'll put in Eli's LinkedIn profile so you can at least connect with him virtually. And he's a great person, a great connector, and we'll also put some resources for you there. I hope you've enjoyed this conversation and help you think a little bit more high level about your engineering career. And we thank you for all the work you're doing. Thank you for being part of our ecosystem. We'll see you next time, but until then, remember to always stay connected to the ecosystem.